Okay, so like I said, I would really appreciate it if you had these open, or at the very least, you have the mass steps. If you printed them out or something, you could have them next to you. So I'm going to have these open side by side because that's the instruction that I'm going to be doing here. So with the type of gas now determined, we can begin to judge the potential health risks to the surrounding populations. Keep in mind that almost all substances are toxic if exposure is sufficiently great. With that in mind, we first need to determine the concentration of our gas immediately following the explosion. This is imperative in determining a course of action for the population living immediately around the industrial complex. So remember, we've had our explosion. So what we're now going to do is model what the gas is going to do starting from the moment of the explosion. So remember what I told you, most of these chemical warehouses, or all chemical warehouses really anywhere in the world, are supposed to be isolated so that they don't have people living in the immediate vicinity. But if you remember back to the article, most of the time that's not the case. People simply don't care. The government doesn't enforce anything, so these things just get built with housing and other people immediately next to them. So when this chemical facility first exploded, the people that are immediately next to them are going to be hit with this gas almost immediately. So the gas is not going to have time to spread out or dilute. So the density of the poisonous gas is not going to be able to lessen. So they're going to get hit with the full impact of the gas. So it's important to know exactly what that density of the gas is at that point, how much gas has been released and is going to is going to expose the people surrounding it to. So this is imperative in determining course of action. So the composition of normal air. So in problem set number 2, we'll be calculating the various measurements and properties associated with unpolluted air. So this will serve as a control. All experiments need a control. Again, this is going back even now to elementary school. Whenever you conduct an experiment, there always needs to be a control. So to compare our contaminated air against. So I'll be grading not only the final answers, but also, again, the work that you show. I don't care about your final answer, to be honest with you. I care about the work that you show. So be sure to be neat and organized. Answer the preceding questions as thoroughly as possible. So your first task will be to obtain the mass of a 22.400 liter sample of air taken at the facility a few months before the explosion. This was a routine Environmental Protection Agency regulation and compliance check. So the results are easily obtained. So again, this is your first question, and I'm not going to do it for you. I'm just giving you the answer because I need it. So then let's go down to the next question. So after obtaining the total mass of our unpolluted air sample, so that's this, there's our total mass of the unpolluted air sample, we need to determine the total mass of each of the gases that make up our sample. So question number 3. Following, I'm providing you with the percent composition by mass of the air. So this air sample that we collected. So the percent mass of each of the gases that make up the sample. So with these figures, you'll convert percent composition of each gas to grams of gas. So this is actually, whenever you take a breath, what you're actually breathing in is this right here. So that air that you breathe in is actually made up of 4 different gases. So you can see here that most of the air you're breathing in, or most of the gas that you're breathing in, is actually nitrogen gas. So for each breath of air you take in, 78% of that air that you take in is nitrogen gas. The oxygen gas, which your body actually uses, only constitutes about 21% of the total air. Then you're also going to be breathing in some argon gas, and you breathe in a very small amount of carbon dioxide gas as well. Now, this is ideal. Obviously, especially in the city, we're also breathing in other pollutants. So there's other stuff that's also in the air you breathe in. But if we had just a pure air sample, this would be the mix of gases that we'd be breathing in. So we're going to go ahead and follow our math steps here. So step 1, identify what's missing within the question and circle it. So this is what people are telling me they can't do. This is too difficult for them. They're just not they're not able to do that. They're very angry at me for asking them to do this. So again, if this is too much for you, If you can't read the question and circle something, then don't do it. Do it however one of your other teachers taught you to do it. But again, I just need to see the work, and that's fine. So I'm going to read into the question. I'm going to circle what's missing here. So I read here and it tells me that I want the mass of each gas. So the percent mass of each gas. So again, I can't really circle here. So I'm just going to highlight this in red. So there we go. There's step one. Step number two, underline the measurements that you've been given. This really sets people off. They read circle and they get angry, and then they read this that I want them to underline a number, and that's it for them. They can't take it. So I'm going to come in here and we're going to underline numbers. So one of the numbers that I have here, and this is why I needed this number, is I have that. And then I'm just doing nitrogen here. So what I'm going to do is you're going to finish these last three. So for the nitrogen gas, I'm going to underline this number. So there we go. So number three, pull out the measurement that you identified in steps 1 and 2. We always start with the measurement you circled and place an X next to it. So step 3 is I'm going to come down here. And I always like to make bullet points. So it helps stuff. It helps me see things more clearly. So I'm going to put a little bullet point list here. So I'm going to put my X down. I don't want that highlighted. That's annoying. Okay. So again, step 3 just simply says write down your X and you write down what it's equal to. So I don't have to worry. I don't have to try and guess what it's equal to because I circled it. It's the percent mass. So what I need here is the mass. And in this case, we're looking at nitrogen gas. So I need the mass of nitrogen. There we go. There's step 3. Step number 4, again, at this point, hopefully you've seen that every single time I do a math question, I'm just following the same steps every time. It doesn't matter what the question is. The steps never change. So step 4 then is to list out the things you underlined. So again, all I have to do is find what I underlined. If I underlined it, I'm writing it down here. I'm not trying to guess what it is. I'm not thinking about anything. I underlined it, I'm writing it down. 78.090%. So there we go. Those are the 2 numbers that I had in my question that I underlined. And then I go on to step number 5. So math is nothing but a relationship. It's a statement of a relationship between measurements. So in order to do math correctly, I need to know what measurements I have. So in step 5, we look at the unit of the measurement and identify and label it. So if I look at this number here, 28.999 G, G is Graham's number. Because I wrote the unit down here, I don't have to go into my question and try and guess what it is that this number is. It tells me right here, this G means that it's a mass number and it can only be mass. So if I go up here, this is the mass of the air sample. So notice I always label whatever the measurement is as well. Where did it come from? What am I measuring? So like we just talked about now multiple times, every chemical substance has unique measurements associated with it. So we always want to know what the chemical substance is that we're measuring. So in this case, we were measuring the total air, the mass of the air sample. So this was our total mass here of the air sample. Then we come down here, 78.090%. So this is a percentage. And I look here, it's a percent of nitrogen. So that's my part of the air sample that's nitrogen. So I'm going to go ahead and just write myself that note there. So there we go. Step 5 is done. Step number 6, we're now going to write the equation down. So we're going to look at what we're talking about here. So what's my science concept? What am I talking about? This is, sorry. So I look at this, so I have a percentage, I have a total mass, and I have a mass of nitrogen. So my concept here is this percentage. So again, if you don't know anything about a percentage, these were first talked about in elementary school. But if you don't know anything about what a percent is, and you didn't do the previous work, I have videos from a video from the Khan Academy talking about what a percentage is. So you can watch that as well. So at this point, we just write down our equation. So I'm going to come in and put the equation in. If I can find it, I can't see anything. There it is. So equation. So my equation for a percentage is always the same. Doesn't matter what you're calculating a percent of. So percent is always equal to the part of something. So at the top, I just write down part divided by the total. And then to turn it into a percentage, percent means per 100. So that means I just have to multiply by 100 to turn it into a percentage. Again, it doesn't make any difference what you're calculating a percentage of. It's always the same. So there we go. There's step 6. I wrote the equation down. Step number 7. In order to solve a math equation, I need something to plug into every spot in the equation. So what I'm going to make sure that I do is check before I start doing any actual math work to make sure that my list that I spent this time making has everything that I need in it. So I'm going to look at this. So my equation requires me to have a percent. So I look at my list and there you go. I do have a percentage. So I have something to put in there. So I'm good to go. Do I have part of whatever my total is? So in this case, I do. So I'm calculating the nitrogen part. So I have something to plug in there as well. Do I have a total? And I look at my list and I do. I have a total air sample there. So I have something to plug into that spot. So my work that I spent this time doing has really paid off because at this point I have everything that I need sitting right here in an easy to read list. And I know exactly where everything goes. So I can go on to step 8. So like I've said over and over again at this point, I used to at this point just do step 9. I just plugged in the numbers. So I would take the numbers and I would plug them in where they would go. But what I found is as you start dealing with more and more complex equations, and especially when you start dealing with numbers like I just taught you, the mole number, those numbers become difficult to move around. So I would find myself making mistakes quite often simply when I rewrote the number on one side of the equation. So I would just make some mistake. I would flip 2 numbers in there, or I would drop a number when I was rewriting it. And I would be getting questions wrong simply because I wasn't copying the number down correctly. So what I decided to do is just move stuff around before I even put any numbers in. And that way I can eliminate that particular mistake that I was making. So in this case, we always check to see where the X is. So for this question, the X, what's missing is the part right here. So I can see that my X is not by itself. So that means this equation has not been solved for X at this point. The way that the equation is arranged right now, it has been solved for percentage. It has been solved for this part of the equation, but that's not what's missing. So that means I need to get the X by itself. And again, I'm all about questions and thought processes that are universal, that I can apply over and over and over again. So this is another one of these where it comes in. So what I realized over time is that I ended up asking myself the same question every time I would do a math equation. And the question was always, how do I get X by itself? And the answer is always the same. It doesn't matter what the equation is you're doing. The answer to that question is always the same. The answer is by doing the opposite of what it wants you to do. So when I look at this equation, there are 2 things that are by the X. I need to get rid of this, and I need to get rid of this 100. So then that's where I ask myself the question. So let's say, how do I cancel this total out? How do I get rid of total? And the answer is always the same, the opposite of what it wants me to do. So I look at the equation, it's asking me to divide. So to get rid of it, I do the opposite. It means that I'm going to multiply. So instead of dividing by a total, I need to then multiply by total. So I'm going to come in here. Oops. And we're going to multiply by this. So I'm going to add a fraction in here. So as I learned more and more math, I started writing everything down as fractions. So I could just, what I could do is simply put total down here. I could do that. That's what I had always done before. But it didn't help me better understand math. When I started writing everything as fractions, it helped me better understand math. So let me put total back in here. I can write it this way, or I can come over here. I can use a fraction. So I can put the total up here, because what can you always do with any number like that, or any word like this or number? You can always come underneath it and you can put a 1. This right here, seeing it this way, really helped me better understand fractions and what a math equation is telling me. So it helped me really better understand this kind of math equation setup. So like I've said again many times, you can do whatever you want to a math equation as long as you do the same thing to both sides. So if I multiply this side by total, so now I can cancel this out. That's fine. I can do that. All I have to do is come to the other side and do the same thing. So if I multiply that side by the total, means I have to multiply this side by the total. And there we go. Now I'm good to go on that. So I've now canceled this part out, but I still have this 100 sitting here. So I need to cancel this. So again, the question, you'll see the question is always the same. The question is, how do I cancel this? The answer then is always the same, the opposite of what it wants me to do. So here it's asking me to multiply by 100. That means I have to, in order to cancel it, I have to divide by 100. So situations like this, you can now see is why I write stuff down as a fraction. So now I can just put the 100 underneath here, because that's really what I'm doing. Oops. So I can now cancel that. And that's fine, as long as I come over here and I do the same thing. So I just put 100 down here. So now you see that I've canceled everything out here that's by the x. Now the x is by itself. One last thing that I started to do is, normally, like in the beginning, what I would do is I would just start plugging stuff in here. I'd go down to step 9 and start plugging numbers in. But every now and then I would get confused. Like I would forget to cross something out, and then I would keep it in my equation. And I would get the answer wrong because I didn't cross something out, or because I was kind of confused by what I saw here. So what I started to do to keep myself from getting questions wrong for that reason is I just cleaned up the equation. So before I plugged in any numbers, I came underneath it and I wrote down what the new equation looked like. So what's left there is that this. So this is what the equation now looks like after everything has been canceled out. So now you can see that the x is by itself. And once I go to step 9 and plug the numbers in, I'm not going to have to move anything around at that point. So when I put these numbers in, I don't have to move anything. So let me go back here. So notice this percentage is sitting here. So I'm going to again show you what I would normally do. And I'm going to go ahead and write that as a percentage, or as a fraction, so that we can again see what may make more sense. This just allows you to see math equations in a different way. So what this says right here, so when you see a math equation like this, what it's really saying is that percent is in the numerator. And in the denominator, again, you don't see anything in the denominator here, but you can always put a 1 in. So I'm going to go ahead and delete this percent. So now take a look at what the equation looks like. This is the same exact thing that you have right here, but it just makes more sense to me. It again allowed me to make better sense of what a fraction is talking about. So now whenever you multiply fractions, you're just going straight across. So percent times the total on top and 1 times 100 on the bottom. So again, it's just a little thing but it helped me really, like I said, better understand what I'm looking at with math equations. So at this point I can go to step 9. All of this work has allowed me to get an equation that now just requires me to plug some numbers into a calculator, and I'll be done. I'll have the correct answer. So at this point, I'm just going to plug stuff in where it belongs. And because I spent the time writing the equation down, I know exactly where everything belongs. So when I go to plug numbers in, I'm not putting them in the wrong spot. So this percentage has to go right there. So let me see. I'm going to copy this. So this percentage is going to be 78. So, and again, I listed everything out, so I know exactly what goes there. Oops. And that is percent. So 78.090, and I've labeled it, so I know that goes there. Then I come to the total part and I look up at my list and there's what I have for total. So my total says 28.99. So 28.999, and I always put my unit of measurement down, grams. And then my X went in over here. So my part was my X. So again, because I did the work already up here, because I moved stuff around in the equation, all I have to do is punch this into the calculator. So I'm going to go to my calculator and plug this stuff in. So we have, and again, notice how I wrote it in the fraction form. It makes it easier for you to see how it's supposed to go into the calculator. So I'm doing 78.090 times 28.999. So we'll punch that in, press equal. And then down here on the bottom, I'm doing 1 times 100. So I'm actually going to show you what this looks like. So I'm going to solve this equation one step at a time. So I'm again going to come in here and put a fraction down. This is actually really important for the math that we're doing with moles. So this is 2,264.54029. And then on top, I have the unit grams. I wasn't able to cancel anything out. And on the bottom, I did 1 times 100. So on the bottom here, I have 100. And then this is going to be equal to X. Okay. So now what I'm doing is I just divide these. So just go in and I divide that by 100. So my answer that the calculator then gives me is 22.64544029. And then my unit of measurement that's left is grams. And that'll be equal to X. So again, this is not the answer you would actually want to write down, but again, I'm not too concerned about this. We would really need to know how many digits to put down in the answer. So this is where the significant figures comes in. So we look at our original measurements and we count the number of digits. 1, 2, 3, 4, 5. So that number has 5 digits. This one has 1, 2, 3, 4, 5. So both have 5 digits. So that means my answer should have 5 digits. So 1, 2, 3, 4, 5. So this is the 5th digit in line. So this is the one that gets rounded. So I look behind it and I see a 4. So that means this number just stays. So my true answer that you would write down is 6.4 grams. And that's going to be equal to the mass of nitrogen. So there's our true answer to that. But again, it's not a huge deal there. So there's the math steps. This is the work that I'm asking you to show. So again, you can see, hopefully you're starting to see as we go through more and more of these, that every question I give you, you can do exactly the same way. The thought process is exactly the same. It greatly simplifies what I'm asking you to do. It greatly simplifies all math by going through it this way. But again, if you don't want to do it this way, you can do it however your middle school teacher taught you to do it, or your 9th grade teacher taught you to do it, as long as I see some sort of work here. And then that's fine with me. My only interest is in that the information is learned. How everyone learns information is going to be different for everybody. So that's the key that I'm looking for on that.